Good evening, dear students. So, in the previous class, we have seen the important concept from this particular chapter, that is carbon and its compound, right? So, today we are supposed to see some of the important questions from this particular chapter. Okay, so we'll go through the important questions which are asked from this particular chapter. So, okay. So we have seen the important concept. So whoever has missed the classes, please go through the previous videos wherein we had uh, we have dealt there with the important concept from this particular chapter, which is asked. Okay. So now we'll see what are the important questions which can be asked from this particular chapter. So the first question is, what is a covalent bond? Okay. So this question, it can be asked for 1 mark. What is covalent bond? Or name the bond formed between carbon atoms. Okay. So the question can be anyhow. Okay. A direct question, or it can be a twisted question. So which is the bond which is formed between carbon atoms? Okay. So we have seen the types of carbon atoms, right? So in types of carbon atoms, what we've seen one is saturated carbon atoms and another is unsaturated carbon atom, right? Then we have spoke about the types of bond, right? So if you have carbon-carbon single bond, what is this single bond? What is this single bond? So it is a covalent bond. So how this covalent bond is formed, students? Covalent bond is formed by mutual sharing of electrons. Okay, mutually the electrons are shared. Okay, between the two atoms. Okay, so when you are sharing an electron pair between two atoms, it is called as a covalent bond. Okay, so what is covalent bond? So what should be the answer from you? Yes, what is a covalent bond? Okay, so what is a covalent bond, right? So the bond which is formed by sharing of electron pairs between two atoms are called as covalent bond. Okay, so when there is a mutual sharing of electrons, so when there is a mutual sharing of electron when takes place between two atoms, suppose I take a hydrogen molecule. Okay, I take a hydrogen molecule. Now what will happen in hydrogen molecule? There are two hydrogen atoms, so each atom will share its one electron. Okay, and mutually a bond is formed between them, and this bond is nothing but what? It is a covalent bond. Okay, it is a Okay, so this is covalent bond. Otherwise, the twisted question, name the bond which is formed between the two carbon atoms. So it is a covalent bond. Okay, so like this, the question can be asked. So mutual sharing of electron takes place between two atoms. That type of bond is called as covalent bond. Okay, so this is the answer you are supposed to write. Okay, fine. Now, next question. So understood this particular question? Yes. So next question. Covalent compounds have low melting points and boiling points. Give reason. So what is the reason why covalent bonds, that is the carbon compounds, they have low melting and boiling point? Okay, so this question is asked for 2 marks. So for 2 marks, at least two reasons should be mentioned. Okay, so what is the reason? Okay, why the covalent compounds, they have low melting point, boiling point? Okay. The first is intramolecular bonds are stronger in molecules. Okay. So the intramolecular bonds are stronger in molecules which is formed of covalent bond. Okay. Intramolecule. What do you mean by intramolecule? Intramolecule means within the molecule when the bond is present. Now suppose in intra now between in your school, okay, in the school within the class, when the competitions are going on, what you call it is a intra school competition. Now when you are competing with other students, okay, other school students, then it is called as inter school competitions, right? So intramolecular bonds means what? Intra means within the same molecules the bonds are formed. So intramolecular bonds are stronger in molecules which are formed of covalent bond, okay. But intermolecular force is very less. But what is happening to the intermolecular force? When you are seeing the intermolecular forces, they are very less, okay. So because of this, the melting and the boiling point of covalent compounds are lower. So this is the reason why covalent compounds are having low melting point, because the intermolecular bonds are stronger as compared to that of the intermolecular forces, okay, between the covalent compounds, okay. So the carbon compounds, they can form the intramolecular, okay, within the molecule the bonds are stronger, okay, whether besides within forming the bonds with the other molecules, okay. So carbon compounds are having low melting and boiling point. This is the reason you have to mention, okay. Next question is what? Covalent compounds are generally poor conductors of electricity. Justify means what? Give reason, okay. So covalent compounds, they are generally poor conductors of electricity. Why they are poor conductor of electricity? Because the electrons are shared, okay. So covalent compounds, how they are formed? Covalent compounds, covalent bonds or covalent compounds, they are found, okay, in which electrons are shared between the atoms, right? How covalent bonds is formed? When mutual sharing of electron takes place, right? And no charged particles are formed. So in covalent bond, what is happening? Okay, suppose I take again the hydrogen molecule. Okay, hydrogen molecule. So what is happening in hydrogen molecule? There are two atoms of hydrogen. So each hydrogen atom, it has a single electron. So this single electron are sharing and it forms a covalent bond, right? It forms what? A covalent bond. Now, when there is formation of covalent bond, can you see any charged particle? Yes, can you see any charged particle? Yes, students. No, you cannot see charged particle. Means what? Can you see H plus? Can you see H minus? This is the meaning of charged particle. So can you see any charged particle? No. So because of this reason, covalent compounds are what? Covalent compounds are generally very poor conductors of heat and electricity. Okay. So this is the reason. So covalent compounds in which the electrons are shared. Okay. Covalent compounds in which the electrons are shared between the atoms. Okay. And no charge particles are formed. So covalent compounds are generally, they are poor conductors of electricity. See, for conducting electricity. Okay. For conduction of electricity. So how the electricity is conducted? If there is presence of free electrons. Okay, if there are presence of free electrons, if free electrons are available, okay, then the electricity is conducted. Okay, now whenever you are having why some of the metals are good conductors of electricity? Because there is presence of free electrons. Okay, so these electrons, they conduct. Okay, they conduct. So because of the mobility of these electrons, some of the elements or some of the metals, they are good conductors of heat and electricity. For example, copper, right? So copper is a good conductor of heat and electricity. So because of this reason, we in the electrical appliances, right, in the wires, so what is present? Copper is present, right? So because of nature, okay, that is covalent compound, because electrons are shared mutually, okay, and there is no presence of charged particles, hence they are poor conductors of electricity. So this is the reason you have to mention. Fine. Okay. So the point should be clear. Okay. For the your justification, your reason should be valid. Okay. So if you write the correct points, okay, if the your points are valid, then you will get the proper marks. Okay, for as per your justification, as per your answer, the marks will be allotted. So this particular question is for 2 marks. Okay. Okay. So next question, moving forward, fourth one. No other element exhibits catenation property to the extent found in carbon compounds. Justify or okay, other forms of question. So how this question can be asked in different manner they have mentioned. No other element exhibit catenation property to the extent found in carbon compound. Means what? No other means what? How this question is framed, that carbon compounds only forms catenation property, or carbon compound only has the catenation property and no other elements exhibits. So what is the reason why only carbon compounds they have this unique property called catenation property, and why the other elements cannot exhibit such property? So this is the simple form. Okay, I have just simplified this particular question. So okay, understood. Okay, so how this particular question is asked, how they have asked that carbon compounds only show the catenation property, why other elements they do not show catenation property, give reason. Okay, they have asked like this. Fine. The other, how the other question, or how it is asked in or. Okay, write to properties of carbon for how it is responsible for the innumerable carbon compounds we see around us. Okay, so what are the unique properties? So the how the second question is framed, what are the properties or what are the unique properties of carbon, because of what this carbon is responsible for formation of so many compounds. So in nature you can see there are numerous or innumerous carbon compounds, right, around us. So whatever we see, the coal, charcoal, okay, your fossil fuels, right, the what you say, so everything, whatever we are using, okay, so wood. So these are all are what? It is made up of carbon compounds. So what is the unique property of carbon because of which it is showing so many, or it is forming carbon compound? So you have to mention, you have to explain those two properties. Okay, so this is the question how it is asked. Now, the next question how it is asked. No more covalent bonds than triple bonds formed between any of the carbon atoms. Why? Okay, no more covalent bonds then triple bonds formed between any of the carbon atoms, and why? Okay, so in carbon atom, maximum number of bond which is formed is triple bond, right? So carbon can form single bond, carbon can form double bond, and carbon can form triple bond. So no more covalent bonds than triple bond is formed between the carbon atoms. Why? Why it cannot form four bonds between the carbon atom? What is the reason? Okay, means maximum number of covalent bonds formed is 3. So what is the reason why it cannot form more than that? Okay, it is the question they have asked, frame. Okay, okay, fine. Or what causes carbon to form the most of the compound? So what is the reason why carbon can form most of the compounds? Okay, then next is what? State the catenization and tetravalent properties of carbon. Okay, what is the unique property of carbon, that is catenation property, and why it shows that tetravalent properties? Okay, why carbon exhibits tetravalency? So what are the properties of carbon that you have to mention? So this particular question, it is asked for 3 marks. Okay, so the how the for these, okay, so the how many questions are asked here? 1, 2, 3, 4 and 5. So 5 questions are asked here. Okay, so 5 questions. So for one answer there are 5 questions. So the questions can be framed in this manner. Okay, understood? So please go through this question. So how the question is framed in different manner. Okay, so for this particular questions, okay, the answer is this. So carbon bonds with other carbon. What is this catenation? Okay, what is this catenation? So catenation is a unique property which is shown by carbon, which is exhibited by carbon. Okay, so what is this unique property of carbon? So carbon has the unique property of self-linking. It is called as what? The word You have to mention this word, okay? Self-linking to other carbon atoms, okay? So carbon atoms, okay, they bond or carbon bonds with other carbon atoms to form a large molecule. So this, okay, how it goes on linking, okay, like that the carbon uh, atoms, it forms a large molecule. So what it is undergoing? It is undergoing self-linking. So this property of carbon undergoing self-linking is called as what? It is called as catenation. What it is called as? Catenation. So what do you mean by catenation? So carbon has a unique property where it can link with its carbon atoms, okay, and it can form a large molecule. This property is called as catenation, okay. So why this carbon atoms can form carbon-carbon bond? Okay, because it is stable. Okay, carbon single bond carbon, it is a stable because carbon-carbon bond is stronger. So this CC bond which is formed, it is stronger. Okay, so the large number of compounds are found in which carbon atoms are linked together. So you can see that a large molecules of carbon compounds are formed, okay, where the carbon atoms are linked with each other, okay. So the valency of carbon is 4, okay. So carbon is what? C6, okay. So when I write the electronic configuration, it is 1s2, 2s2, and 2p2. So in its outermost electrons, how many electrons are there in its outermost shell? 4 electrons. So carbon has a tetravalency, means what? Carbon can have at the most 4 bonds, okay. So carbon is capable of combining with 4 other atoms or with a single valence electrons. Okay, so it has a tetravalent property. So this is the tetravalency, means what? Carbon can exhibit 4 bonds. Okay, it is having the capacity, or it is having the combining power to combine or with other 4 carbon atoms. Okay, or other atoms. Fine. The bond that carbon forms with other elements are quite strong. So carbon can also form the bond with other element. Okay, carbon, hydrogen, carbon, nitrogen, carbon, sulfur. Okay, carbon, oxygen. So this bond formation is also quite strong, okay, making this compounds more stable. So carbon can not only link with carbon atoms, but it can link with other atoms also. It can link with hydrogen, it can link with nitrogen, it can link with oxygen, it can link with sulfur, okay. So because of this reason, it makes the compound more stable, okay. So this is the reason why carbon, okay, has a unique property of catenation, how it exhibits a stable bond, okay, and because of this reason why it is stronger, and how it exhibits a tetravalency compound, okay. So this is the reason. One more reason is that carbon forms strong bonds. Why? Because of its small size. Okay, so because of its small size, so carbon, because of its small size, it has the ability, okay, to form the strong bond. So because of this reason, it can form strong bonds, okay. So this causes the electrons to be strongly held by the nucleus. Why? What is the reason of small size? So because of the small size, the nucleus, okay, you know that the nucleus is in the center, and around the nucleus, the electrons are revolving. Okay, so in the first shell, you have 2 electrons, right? In the next shell, you have how many electrons? 4 electrons, right? 1, 2, 3, 4. So because of the small size, the nucleus, what it will do? It will hold the electrons more tightly, okay? So these electrons which are there in the outermost shell are, they are held very tightly, okay? So because of this reason, the bonds are more stronger. So because of the small size, the electrons, okay, the nucleus will hold the electrons more tightly, okay, more strongly. So because of this reason, the bonds are strong, okay. So this is the reasons, or these are the points you have to mention. Is it clear, students? Yes, is it clear? So we have seen 4 questions till now. Is it clear? Any doubts? Yes, any doubts, students? If you have any doubts, please ask. Okay. Moving forward, I hope there are no doubts. Okay. So, moving forward, next question. Name the compounds with the structural formula having the molecular formula C5H12. What are structural isomers? Write the structural isomers of pentane. Okay, so this question is for 3 marks. Yes. So what is structural isomers? Yes, can anyone tell me? Yes, what do you mean by structural isomers, students? So, name the compounds with the structural formula having the molecular formula C5H12. What are structural isomers? Write the structural formula of isomers of pentane. Okay, so compounds. So when you have compounds with same molecular formula, okay, so compounds with the same molecular formula, but structural formula is different. Suppose I take an example of butane, okay, that is C4H10. So I can write it as 1 CH3, CH2, CH2, CH3. Count 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So this is N-butane. Okay. Now, so one more. Now you can see. Yes. See the number of carbon atoms. See the number of hydrogen atoms in each case. Yes. Carbons are 1, 2, 3, 4. So C4, hydrogens are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So H10. Then here 1, 2, 3, 4. Carbon is C. 4. Hydrogens are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. So what you can see in both the structures? Yes, students. So what you can see that both the molecular formula is same. Right? In both the cases, the molecular formula is the same. Is the structural formula same? Are the molecules same? Structurally, yes, structurally is the same, no, right? So the compounds which are having same molecular formula but different structural formula, they are called as structural isomers. What they are called as? They are called as structural isomers. Okay. So compounds which are having same molecular formula but different structural formula are called as structural isomers. So these are examples. So you can give, so this is a isobutane. This name is isobutane and this is N-butane. Okay. Straight chain compound is called as N-butane. Fine. Now, so these are the example, other examples are given as okay, they have told name the compounds with the structural formula having the molecular formula C5H12. So when you have C5, okay, what it is called as? It is called as pentane. Okay, it is called as pentane. So one structural. So the first structure you can write it for N-pentane. Okay, so you can see N-pentane. So number of carbon atoms 1, 2, 3, 4, 5. Okay, so CH3, CH2, CH2, CH3, CH2, 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 and CH3. Okay, so this is the N-pentane. So this is the structure for N-pentane, right? And pentane. So here the number of carbon atoms are 5. Okay, and this is the formula. Fine. So CH3, CH2, 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 and CH3. You can see. Count it is C5H12. Okay. Now, second structure is they have written here isopentane means carbon atoms straight in a 4 and here a branch carbon atom with 3 hydrogens. So here also it is C5H12. Okay, so this is a isopentane. Next, how they have written next is neopentane. Okay, how they have written 1, 2, 3. Okay, then here hydrogen, here hydrogen, here hydrogen, here hydrogen, here hydrogen, here hydrogen. Here this carbon, hydrogen, hydrogen, hydrogen. This carbon, hydrogen, hydrogen, and hydrogen. Understood? So count now. Again, it is C5H12. So this is neopentane. This is called as what? Neopentane, where carbon is tertiary carbon because it is attached to other 3 carbon atoms. Okay. It is a quaternary. You can see it is a quaternary carbon. So carbon is attached to 4 other carbon atoms. So it is called as quaternary. Okay. So these are the different structural formula of C5H12. So it can exhibit 3 structural formula. Okay. Structural formula. So you can see different structural formula. The molecular formula remains the same, but there are 3 structural formulas. So this is the meaning of or this is a definition of structural formula. Okay. Isomers, structural isomers. Okay. Next question. How are saturated and unsaturated carbon atoms different? Okay, how are saturated and unsaturated carbon compounds different? Or the question is asked as alkanes are chemically stable, but the alkenes and alkynes are not stable. Okay, alkenes and alkynes. Alkynes. Alkynes are not stable. Justify means give reason. Okay. What is the reason? How are saturated and unsaturated carbon compounds different? Or the question can be alkenes are chemically stable, but alkenes and alkynes are not stable. What is the reason? Yes, what is the reason, students? So this particular question is asked for 2 marks. This question is asked for 2 marks. So they have asked you the difference between the saturated and unsaturated compound. So you have to make 2 tabular. In one, you have to write about saturated carbon. Another, you have to write unsaturated. Now, saturated carbon atoms are found where? When you have carbon-carbon single bonds. Okay, so carbon compounds with carbon single bonds. Okay, or carbon compounds with only single bonds between the carbon atoms, okay, are called as saturated compound. What do you mean by unsaturated? Unsaturated carbon compounds are those with carbon double bond carbon or carbon triple bond carbon. Okay. Now saturated compounds are not very active. Okay. They are not very active, and unsaturated carbons are generally more active. Saturated carbon compounds, they are called as alkanes, and unsaturated carbon compounds, there are two classes of classification in that, alkenes and alkynes. Okay. Alkynes. Understood? So alkenes and alkynes. So these are the set of differences you need to write for this particular question. That is how unsaturated and saturated carbons are different. Or the question is alkanes are more stable, but alkenes and alkynes are not stable. What? Okay. Justify like that. So for 2 marks, this is the answer you are supposed to write. Fine. Next question. Which is the first member of the group of ketones? Write its atomic formula and structural formula. So this question is also asked for 2 marks. So which is the first member of the group of ketones? Yes, so which is the first member of the groups of ketones? So the first member of ketones is propane. Okay, P-R-O-P-A, propanone. Okay, propanone. Because you have a ketone, the suffix is on, O-N-E. Okay, propanone. So what is the molecular formula? It is CH3, C double bond O, CH3. Okay. So the structural formula they have illustrated as C like this. Got it? So this is the structural formula. So this is the answer you are supposed to write. Fine. Next question. Methanol, ethanol, propanol, and butanol. They have similar chemical properties. Okay. Methanol, ethanol, propanol, and butanol. They have similar chemical properties and general formula. Give reasons with their molecular formula. Okay. So these alcohols, so these are the set of alcohols, that is methanol, ethanol, propanol, and butanol. They have same or they have similar chemical properties and they have a general formula. Okay. Give reasons with their molecular formula. So give the reasons for their molecular formula, or what is homologous series? State the homologous series properties of the first four membered molecular formulas of alcohol. So the question is asked in two ways, okay, about the alcohols. So what is homologous series? And you have to mention the properties of the first four member of the alcohols, okay. So this question is for 3 marks. So the molecular formulas of the first four members of alcohols are, first is methanol. Okay, so when you have one carbon atom, so it is methanol. So it is CH3OH is methanol. Then ethanol is C2H5OH. Okay. Then propanol is C3H7OH. And butanol is C4 H9OH. Okay, so this is about the molecular formulas. Okay, so this is the molecular formula of the alcohols. Okay, now what is so here what is happening here? Okay, methane is CH3, CH4. So one of the hydrogen atom is replaced by your OH group, right? So a series of compound where a single reactive group is displaced in the hydrogen. What you can see in this, that a hydrogen is been replaced by a reactive group, that is a OH group. Okay, such a series is called as the conformational series. Okay, so you can see that the same, so these members, okay, they are having the same general formula. They are having the same functional group. The difference between this four is that there is a difference of CH2 group in the each successive member. Okay, and the mass difference between the each member is minus 14 unified mass. Okay, U resembles your unified mass, and they are having all the four alcohols. Okay, they are having same chemical properties. What they are having? They are having the same chemical properties, right? Okay, so this is about your what about your alcohols. Okay, that is you have to write. So these are the four members. Okay, how they are, how the, what are the similarities, so they have asked. So these are things to be mentioned. Okay, so next question. I hope you are writing down the things, right? Yes, are you writing down the things? So these are important questions. Please make sure that you write these things. Okay, next question. Identify the compounds which decolorizes bromine solution in C6H12, C3H6, C6, H14, C6H10, C3H8 and give suitable reasons for it, or state one chemical test that can be carried out to distinguish between saturated and unsaturated hydrocarbons. So this particular question is asked for 2 marks. Okay. So whenever you have a saturated, now what is bromine test? Okay, what is this bromine test? Now this bromine test, what they have given. Okay, so this particular test, it is used to what detect, it is used to detect the presence of double bond or triple bond. Okay, whether there is a presence of double bond or triple bond in a particular compound. Now, when do you show a positive test? Okay, suppose I have a compound, okay, which is having a double bond. Okay, I react it with bromine water. What will happen? It will show decolorization. Okay, it will show decolorization. Means what? The bromine water, okay, it will be brown color. So this bromine water will get decolorized. Okay, it won't be brown anymore. So means what? That the given compound contains a double bond. So this is the test which is shown positive. Now whenever you have a single bond, suppose I have a compound and it has a single bond and I add bromine water to that, so what will happen? The bromine water color will remain the same. Okay, the brown color or the orange brown color, it remains the same. Okay, there is no colorization. Means what? The given compound is having a single bond. So saturated hydrocarbons, there is no change in the brown color of bromine. Okay, and unsaturated hydrocarbons, brown color of bromine will disappear. Okay, then in saturated hydrocarbons, butter does not undergo hydrogenation reaction, and in unsaturated, cooking oil, okay, cooking oil, it undergoes hydrogenation to convert into solids. Okay, so these are the main differences, okay, which are to be written for saturated hydrocarbons and unsaturated hydrocarbon based upon the bromine test. Okay, so based upon the bromine test. Okay. Next question. If you notice that the cooking gas or kerosene stoves used in your home are producing black colored smoke in large quantity with black colored flame, and the button surface of the cooking utensils is black in color, what should you do? Okay, so this particular question is for 3 marks. So when you see that, when you're burning, okay, the cooking gas, whatever, where the stove you're burning, you're cooking the food items, okay, If the why it shows black color? Yes, it is due to oxygen supply. If the oxygen supply is very less, okay, if the oxygen supply is very less, okay, now okay, when the flame is burning, okay, properly, means what? There is a proper proportion of fuel, there is proper proportion of air, okay, then the flame will burn properly, okay, means what? It will undergo combustion properly. If there is incomplete air, okay, the proportion of air supplied is less, if the fuel supplied is less, means what? It is undergoing incomplete combustion, okay. So whenever the supply of oxygen is very low or it is very less, means the fuels have incomplete combustion, okay. It won't what you say, uh, the fuels are not ignited properly, or it won't get undergoes combustion properly, okay. So because of this reason they give a black flame, okay. So cooking gas, these are kerosene stores, so they have openings for air supply, okay, so that the air holes are blocked and fuel is being wasted, which means that the air holes are blocked and fuel is being wasted, okay. So when the air holes are cleaned, if the air holes are clean, the air intake will increase and the fuel will burn and you will get a clean blue color flame, okay. And when there will be sufficient, so if you supply sufficient oxygen and the air valve is clean properly, then obviously because of the proper fuel intake and proper oxygen supply, the flame will be you will get a clean blue flame, okay. There won't be incomplete combustion, proper combustion will take place. So these are the things you have to mention. Is it clear? I hope these questions are clear. Yes, so we have seen some 10 questions now. So we are left with few more questions. So these questions we'll be taking in the next class. Okay. So any doubt? Yes, students? Any doubts? So we have seen 10 questions today. Some more 10 questions are there, 10 to 12 questions. So those 10 to 12 questions we'll be taking in the next class. Okay. Any doubts? Yes, if you have any doubts, you're free to ask now. Yes, any doubts regarding today's session? If you have any doubts, you can drop your doubts in the chat box. You can drop the message in the chat box if you have any doubts. Everything is clear? We are seeing the important things. Okay, this will only come, I won't assure you, but these are the important concepts or important questions which you have to study. Okay, so these are the important concept or the questions which are important from this particular what chapter. Okay, so differences between unsaturated. It is not that this particular type of question only will come, but the concept will be similar. Okay, suppose they may ask you, give the differences between saturated and unsaturated compounds. Okay, give a reaction, show that how ethanol is undergoing oxidation to form ethanoic acid. So give an example like this. So the matter remains the same, the concept remains the same, the way of asking the questions will be different. Okay, the approach will be different every time. They won't ask you the similar way. Okay, so the concepts will be the same. The important things are the same. Only thing, the way of approaching will be a bit different. Okay, so please go to the things which have been told. Fine. So at last, your approach is very important. Okay, you have to do the work smartly. Fine. You have to study smartly. Fine. So I hope today's session is clear. So we'll meet in the next class. Okay, so I'll end the session here. So we have some more 10 to 12 questions. So these 10 to 12 questions will be dealing in the next class. Thank you. We'll meet in the next class.